Okay, thank you for joining everyone on our afternoon training session. Today we've got our special guest speaker, Michael Sade from HIA, who's the Director of Building in the HIA. So Michael's going to run through a few things about some benefits to HIA, but also is there construction codes there, Michael? I might let you present that part.
Yes.
To do with masonry, brick and construction.
Yes, so I'm just going to touch on some of the common issues around brick and construction, particularly that stuff that the Building Commission in New South Wales is picking up as part of their audit program. So I'll just touch on some of those requirements under the NCC.
Perfect. All right. Well, we've got a few guests arriving now, so it's a good time to start if you're ready. You've got something prepared there to show on screen, or
yep,
or otherwise.
I'll give this a whirl and see if it works. Window. Okay. Is that sharing at the moment?
We've got that, yes.
All right, let's see if this works.
If anyone's got any questions along the way, feel free to raise your hand and I'll see if there's a good opportunity to bring that in. Otherwise, we'll open the forum at the end for some quick questions as well. All right, thank you, Michael.
Okay, so like Tim said, we'll just start off with a very short video just on HIA and what the benefits are, if you're a member, and also if you're not a member, what benefits you might be able to get if you do join. So hopefully this video works. Let me know if there's nothing happening when I go to the next slide. So here we go.
Responsible.
Perfect, we've got sound.
Okay.
Our members are responsible for building and renovating 80% of the new homes in Australia. There are a lot of challenges that characterise the industry, and a way that HIA can assist members in navigating through that is through providing timely, concise and relevant information. The information that we deliver is written in a way that everybody can understand. As a HIA member, you absolutely do get tailored advice specific to your needs. Our advisors are ready to take your call, and we will take as long as required for you to understand what is truly needed to resolve your problem or your inquiry. Our technical and workplace advisors are highly experienced professionals who are equipped with understanding the legislation, so they ensure that you are compliant, and they are there to answer any of your queries with relation to building. But joining HIA is quite simple. You can go onto our website hia.com.au and you can sign up online, or you can contact one of our offices and speak to our local friendly business development representative. Once you apply to become a HIA member, obviously we have to do some checks and balances, and you will be required to provide some documentation depending on your state. If you are in a profession that is regulated and it's deemed necessary by your particular state, we'll ask you for verification of that. You also have to be an ABN holder. Although if you are a budding industry professional, you're a student, or if you have retired and still want to remain connected, you can also be a member and we won't need an ABN from you. As a HIA member, you are bound by a code of ethics which shows your integrity and your credibility as a HIA member, something that our members are very proud of. We want our members to work towards a higher level of standard so they can continue contributing to the housing industry.
Yeah, so that's just a quick wrap of what HIA can do and as a member. So if you're interested, if you're not a member already, feel free to reach out and I'm sure we can put you in touch. If you are a member, obviously there's some of the benefits that you can take advantage of if you don't not familiar with. There's also other things, but yeah, so feel free to reach out if or jump onto the website if you wanted to find out a bit more. So
perfect.
Moving on.
Go on there. Just want to make a quick note as well that as part of an Integrity New Homes franchise, we've got a 20% discount for HIA membership as well. So if you're looking to join, it's a good time to do that.
Thank you.
Thanks, Michael.
Yeah. So now I'll just sort of touch on one of those sort of areas where I said I'm a technical advisor. Sort of I've been in building certified. Also worked in government. So basically, what my role is to answer those questions that people ring up about and have about a particular job or an issue or something like that. Then we're there to try and help. So these are probably some of the issues in this sort of presentation that cover off on that, and a lot of these issues around brick construction and masonry construction are also issues that the Building Commission has picked up in their audit. So yeah, they're quite common issues and quite common in their orders, and obviously we're just trying to help people to avoid those issues coming up down the track. So I'm just going to briefly cover off the NCC Indemnity Satisfier provisions. I'll look at DPCs, flashings, termite barriers, control joints and windows, the need to keep cavities clear, as well as a wall tie installation. So starting off with the NCC compliance structure and how it works. So for houses, there are 3 different deemed to satisfy options. These options are set out in provision H1D5 of NCC 2022 Volume 2. So it is, if you're doing brickwork or masonry, you have 3 different separate compliance pathways. They're all equivalent in terms of compliance. They're all deemed to satisfy. There is also the option of doing a performance solution, but in terms of deemed to satisfy, these are 3 separate and different compliance. You can't mix and match between the 2 unless you do a performance solution. So if you do choose one, then obviously you need to stick and comply with that one in its entirety. So the first option in there is the use of Australian Standard 3700. The 2018 edition is referenced in the 2022 NCC. It's also referenced in Volume 1 for multi-residential and commercial buildings, and it is the only reference in Volume 1. The second option is to use the AS4773 series, which is basically masonry small buildings. There's 2 parts to this, Part 1 and Part 2. Part 1 is a design standard, Part 2 is a construction standard. And this is only referenced in Volume 2, and it's more for housing, designed for housing, more of a recipe type style as opposed to an engineering standard, which AS3700 is, and it's probably more common in for housing construction. The final option there is complying with Part 5 of the ABCB housing provision standard. Again, it's still an equivalent option, but it does have some limitations. It's only up to a certain wind speed. It's only on a Class A and M site and not in alpine areas, not on buildings requiring earthquake design, and does not cover reinforced masonry. So each of the standards do have similar, but then also different options. So it's important to know which one you're using and making sure that all your trades, your bricklayer knows which option that you're choosing as part of your project. Because when we talk about things like expansion joints or articulation joints or those sort of things, the options, the requirements within them can vary a little. So the first issue I'm going to talk about is around the DPC, and it's probably one of the most frequent issues reported by the Building Commission in New South Wales, and that the DPC, or the damp-proof course, is not visible on the outside face of the brickwork. So as you can see on the slide, we've got a couple of different images there. We've got one of just a face brick and then one of a masonry veneer, a rendered face. You can see on that sort of top photo that the DPC is actually sort of about 10 mil or so in from the face of the edge of the brick. This is actually an incorrect installation. The DPC needs to actually come through and be flush and finish and be visible from the outside face. Again, similar to also on that bottom photo, we've got a rendered wall. We've got a weep hole there, which obviously we assume the DPC is at the base of that weep hole, acting as a cavity flashing, and there's no evidence of that DPC coming through that wall. Both of these photos are incorrect installation and can lead to rising damp and degradation. Also, fixing it is not easy at all. So obviously, not having a DPC coming through can allow moisture to migrate up the wall past the level of the DPC through capillary action or through the mortar in the render coat. And again, does not comply, no matter which standard you use or which compliance pathway is, it doesn't comply with them. All the standards require the DPC to come through the wall. In some cases, I said rectification is difficult. In some cases, depending how close it is to the edge, you might better scrape out a little bit of mortar to expose it. But otherwise, you're looking at either removal of the brickwork and reinstallation, cutting out a course of brickworks, a couple of bricks at a time to try and reinstall the DPC, chemical treatments of like injectable DPCs, those sort of things, but they're not most of those are not DTS options and will need to be agreed with the relevant stakeholders as a performance solution. So, like I said before, all the deemed to satisfy standards require the DPC to be visible at the face of the wall, even after the application of a render or finish. After the wall has been constructed, the DPC can either be cut flush or can be turned down for a metal DPC. So here in the image, this shows what the DPC should look like. It comes through all the way, so in some cases comes a little bit past, it doesn't need to, but basically there needs to be evidence of that DPC basically on the very outside edge. Other things to consider is the proper material selection for your DPC. So materials complying with AS 2904, so polyethylene sheets and bitumen or PE coated aluminium sheets are typical DPC materials. And the standing also includes other options like bitumen impregnated fabrics. Also you need to consider your laps at your corners and at your junctions of those 150 millimeters, and obviously the full width at the corners, and also making sure that your DPC has enough clearance to the ground level. So depending on what type of ground level you have, you're looking at between 50 millimeters and 150 millimeters of clearance. So if you've got a paved area that's covered, you can reduce that clearance between the DPC and the finished surface level to around 50 millimeters, 75 if it's uncovered, or then looking at 150 pretty much for everything else. So when we look at DPCs and flashings, there's obviously a DPC, but there's also a flashing, and the flashing isn't always acting as the DPC, but where it is, it needs to be visible from the face. So where the flashing is separate to the DPC, then it depends on which standard it is using and where the flashing is located. So for example, like a window flashing or a head flashing, it's not necessarily acting as a DPC, so the requirement there is not necessary for it to come all the way to the outside. So if we're looking at the housing provision standard, if it's acting as if it's a cavity flashing, or at the base of the wall or something like that, then it needs to come out through to the face. If it's again a roof abutment, again it needs to come all the way through the face. But if it's sill or head flashing, it only needs to come in around 30 millimeters into the face. So it doesn't need to come all the way through the wall. For AS 4773, cavity, sill and head flashings similarly don't need to come all the way through the wall, but if you've got a roof abutment flashing, then it does. And for 3700, if you're using that standard, then you're looking at following the engineer's design, because obviously AS 3700 is an engineering design standard. So what about your termite barrier? If you've got a termite barrier that's part of your DPC as well, or just above your DPC. So you can have the DPC integrated to termite barrier. I think there are a few on the market. But it too, if you've got a termite barrier as a perimeter cavity, like a blanket or something, or a sheet, chemical sheet as the perimeter barrier, it too also needs to come through and be visible from the outside. It's something to be mindful of. You can't again have it sit 10 mil in because it's not going to provide you that continuous treatment. And obviously there is a requirement of AS 3660 Part 1, which requires the edge of any sheet-based termite barrier to be exposed even through the render. So if you've got using a sheet or a chemical impregnated sheet or something like that as your termite barrier, or then it needs to come through and be visible on the face of the wall, similar to your DPC. So the second issue I'm going to talk about is articulation joints not being continuous past the windows. It is something that seems to be more and more in the findings of the Building Commission in New South Wales, that they're picking up on the fact that the articulation joints are not continuous. Where they've got an articulation joint at a window, that joint is not continuous up through the window itself. So in sort of this diagram here, we've got the articulation joint, which is below the window, and then it also then starts again up above the window, but it doesn't run through the window itself. So there are quite a few orders and rectification orders being issued by Building Commission New South Wales where this occurs. So in terms of what the standards say, it basically depends on which standard you're using as to what is required in this sort of circumstance. In our opinion, because the housing fringe standard only specifically mentions joints between masonry elements, and a window is not a masonry element, The requirement for a 10mm width joint does not apply next to the window under the housing provision standard. However, other standards would imply a joint must be continuous for the full height of the wall, including beside all windows or doors. So if you look at the second there, AS4773, it's quite specific and says a control joint placed at an opening, and a control joint includes an articulation joint and an expansion joint. It basically says it shall provide clearance to the door and window frame to accommodate any movement and remain weatherproof. Similarly, AS3700 talks about the joints extending the full height of the masonry. Obviously, if you're doing a Class A and S site, then articulation joints aren't required because you don't have the excessive slab movement. So due to the differences in approach and wording across the standards, there is still quite a bit of confusion in the industry about what the requirements are for control joints and whether they need to be continuous or not at the windows, and also how to actually do it correctly, particularly if you've got windows and your windows obviously designed generally to the brick opening sizes. So it needs quite a bit of adjustment in terms of your brick width or how you allow for your brickwork to provide for that 10mm clearance. So there's probably a way where you can avoid the confusion altogether. Often we do place control joints beside windows and openings because it may consider gives a better appearance or helps to hide it. However, you don't need to do it next to a window. It's not a requirement that it has to be next to a window. Obviously, it's a certain distance from the window, but doesn't have to necessarily be at the window itself. So the control joints can be located at other locations in the wall, and with careful planning, there is potential to conceal many of these behind or next to other features such as downpipe. So something to think about and to avoid all those other issues, maybe not necessarily putting your articulation or control joints at your window exactly. So we can see in the diagram here from the NCC, we've got six articulation joints, and you can see where they're located by those little figures. None of them are actually directly at the window. They all within 1.2 of the window, but not directly at the window. So something to think about, and to avoid that confusion and the risk of having an issue is maybe place your articulation joint close to your window, but not necessarily at the window itself. But obviously, if you do want to put out the window, it might be wise to think about allowing that 10mm expansion at the window all the way through, and then adjusting obviously your brickwork to suit. There is one issue though, if you do move your control joints away from the window, that does resolve the masonry detailing problem, but there is another provision that also needs to be mindful of, and that's in the window installation standard, such as AS2047 or Part 8.2 of the housing provision standard. AS2047 requires sufficient space around the window to accommodate thermal and structural movement, and any gap is to be sealed with suitable flexible mouldings or flexible caulking to resist water penetration or other weatherproofing methods. Part 8.2 requires a 10mm gap between the top of the window and any load-bearing framing or masonry. It has no requirement for sides of windows, but recommends isolating bare aluminium from contact with masonry. Probably, again, also check with your window supplier for installation details. But there is, when it talks about the gap around the window, it doesn't prescribe a distance. It just says you need a gap. So again, something to be mindful of, that there is a requirement around the thermal expansion requirements, but again, probably something to have a chat to your window supplier about. The next issue is fairly, I guess, basic to some extent, and that's about making sure you keep your cavity clear. Obviously, we have cavity masonry and masonry veneer. We have the cavity there as a weatherproofing requirement. So if we've got mud and other debris or whatever in that cavity, it's going to create issues from a water ingress or not allow that cavity to drain correctly as it's designed. So obviously, it's quite common to have those sort of water droppings, building debris, waste, or even pipe work in the cavity, and obviously, which was going to impact on the drainage and prevent that cavity from draining as down to the base of that wall. So all the masonry standards require the cavity to be kept clear of mortar droppings, other materials or obstructions that may allow the transmission of water. Weep holes as well need to be kept clear of mortar or other materials. Obviously, there's minimum cavity widths for the housing provision standard. We're looking at between 25mm and a maximum 75. For AS4773, it's Part 2, it's at least a 25mm cavity or if you're using AS 3700, then you're looking at a minimum cavity width of 40 millimeters. As I said before, your cavity also needs to be clear of any pipe work. So you can still run pipe work in a cavity. There's nothing preventing that, but you still, but in running that pipe work through the cavity, you need to maintain your width. So if you require a 25 mil cavity width, then that cavity width needs to be measured to any pipe work, not to just the wall frame itself. So if you're going to do it, you need to obviously ensure your services are installed against the frame. If those services are crossing the cavity, like wall presentation for taps or something like that, then they should be sloped to drain to the outside. Different wall ties will have different maximum cavity width as well, so you must select an appropriate tie for the cavity width you need. Factor in the additional width required for any service while maintaining the minimum clear width. This is a diagram as an example only, showing a pipe penetration where obviously we've got a slope to the wall, we've sealed it at the edge. So any water that does set on that pipe is going to drain to the outside rather than back into the framework. And similarly, that wall tie just above, it's also sloped to the outside. So if you do get any moisture on that wall tie, it's going to drain to the brickwork and therefore be able to drain outside and not cause any moisture issues inside that cavity itself. The final group of issues I'm going to talk about are around to wall ties. So there's a couple of different things we can look at here, and that's the durability or incorrect durability, incorrect strength or spacing, some damage to the building membranes, and as I touched before, also about how you install it in the slope. So if you obviously slope that wall tie downwards towards the frame, any water is going to drain back towards the frame, which is not a good idea. So you want to make sure that your wall ties are turned upwards and obviously sloping in a direction towards the masonry itself. So regardless of which masonry compliance pathway you use, your wall ties must comply with AS NZS 2699 Part 1. For the durability, it depends on your distance from your coast and if that coast has breaking surf or not. So for the housing improvement standard under 5.6D, if you're less than 1 kilometre from breaking surf or less than 100 metres from non-surf salt water or in heavy industrial environments, you need 316L stainless steel or engineered polymer. For 1K to 10K from the surf or 100 metres to 1K from non-surf, you're looking at galvanized steel or stainless steel, and everywhere else you're looking at minimum of galvanized 300 gram per square metre of galvanized steel. If we go to 4773 Part 1 in Section 4, we're looking at R3 ties for 100 metres to 1K from the surf, from a non-surf coast or 1 kilometre from a surf coast. Severe marine closer to the coast is R4, and where you're 200 metres from breaking surf, you're looking at an R5, which is a specialty type product. And then if you're looking at AS 3700, it's going to be based on engineer's design, so you need to follow your engineer's instructions. AS 4773 and AS 3700 are similar in terms of the wall ties, but there are some additional exposure environments in AS 3700. So checking the colour code or stamp on the ties or checking the discarded boxes or bags will help determine if your bricklayer is using the right tie for you. Generally, a green is for an R0 or R1 tie, yellow for R2, a red is R3, or white or blue for R4. If you're using an R5 tie, then there's got special labelling provisions under the standard for those. Type B ties are not typically specified in Australia, but are standard in New Zealand. So just making sure you're selecting the right wall ties in terms of strength and spacings. So in terms of HPS, HPS, the requirement, if you're looking at an N speed up to N2, we're looking at a light duty tie. More than N2, then you're up to a medium duty tie, and we're looking at a 450 studs, 600 mil vertical spacing, or if you've got 600 mil stud spacings, then that vertical spacing comes down to 400 millimeters. AS 4773, we're not more than a 600 mil vertical spacing. Again, the wind zone will determine the horizontal spacing. Sorry, the wind zone and horizontal spacing will then determine what type of duty classification. So again, depending on which standard you use, it's going to have different requirements for that and how you determine it. So again, why you need to be mindful and upfront, so it's clear everyone in your process knows which standard you're using as your compliance pathway. 3700, we're talking sort of generally 600 in each direction, but again, it's going to come down to your engineer's design if you're using 3700 for your brickwork. So as an example, under 4773, if you've got an N3 wind zone, we've got a 2.7 metre and 3 metre high walls with a 600 stud spacing, we need a medium duty tie. If we go down to a 2.4 metre wall and wall with a 450 mil stud spacing, we can go down to a light duty tie, even though we're in the same wind zone. Going up to an N4 zone, all wind ties require medium duty, and at N5, looking at heavy duty at 600 mil studs. And just a couple of things on plywood building membranes. So if you do have a plywood membrane external wall, obviously you can't have holes and tears in that membrane. They must be taped and sealed. Leaving a hole or tear will compromise the membrane performance, and under wind load, the hole or tear may get larger. If the membrane flaps across the cavity, it also provides a path of moisture to get into the wall and creating an issue with weather tightness. HIA has become aware of this issue becoming a problem, especially where medium duty wall tie is required in steel framing. So generally speaking, there's issues around those wall ties. Using a medium duty wall tie, because obviously generally they're not face fixed, they're side fixed, and there's issues with the steel framing not being able to cope with the performance and the requirements. So because the steel frame is not strong enough, it is something that the standards committee is aware of and is looking at. So if you do have steel framing and you do need medium duty ties, it is something to consider. The main reason is that because there are no face fixed ties on the market for medium duty on steel framing, only the side fixed. So yeah, so it's something to be mindful of. If you do have steel framing and using side fixed ties, there is you're not going to be able to get a fixing mechanism because the fixing has to come with it that fits with that steel framing. So it is something to be mindful of. So those sort of issues then become, well, do you actually need a building membrane in the first place? So if we're talking water and condensation management, if you have a cavity behind or a water control layer behind the water control layer, so your brickwork, then, or even arguably a lightweight wall, if there is a cavity, then technically speaking, you don't need to have that plywood membrane behind it. So the water control layer is defined as external cladding. Where a membrane is not installed for masonry, the water controller would be the external leaf. So as a building membrane is not required in the housing provision standard condensation provisions and not specified in the masonry standards, a building membrane is not required in brick veneer construction or cavity brick construction either. You may be using it for things like energy efficiency or other sort of things, but it's not required from a masonry or condensation management perspective. So whether deciding whether or not you want to plan to delete the wall membrane from your plans, like I said, just consider the other sort of things like the energy efficiency or even bushfire as well. Although AS3959 doesn't require wall sarking for masonry and veneer, but where you've got buildings combining a mix of masonry and cladding, where sarking is required, but for steel frame, you can also use the Nash bushfire standard as a DTS, which doesn't require sarking for clad walls. And again, obviously, the R values from an energy perspective, and if you need that sarking there or building membrane there to achieve your energy efficiency requirement, or is there another way of achieving that? So that's a very quick rundown of some of the issues from brickwork. I know I've gone a little bit over, but if anyone has any questions, I'm happy to try and answer them if you have any questions on what I've discussed before.
No, that's perfect typing there, Michael. We haven't had anyone raise their hand for a question yet, but please do if someone has a question. Got Brendan here. I'll just allow your mic there, Brendan. You should be good to go.
Brendan, you might be on mute.
Allowed your mic there, Brendan. You just have to unmute yourself from your end as well.
You hear me?
Yep.
Yeah, have you got any pictures of the expansion joint against the window? Because I can't see how it works without being pretty bloody ugly.
Yeah, so what you would have to basically do is you wouldn't run the actual joint itself up there. Generally, what you would, the way you would do it is you would cover it with a store mold. So basically, what you would do is you would have your window and you'd have your gap between the window, and then you'd basically have an aluminium angle or something like that, similar to the material window, but you'd actually fix it to the brickwork, not to the window, to allow that movement across the window, basically. So you could also seal it with a silicone seal or something like that, but obviously, like I said, it's going to be aesthetic unpleasing. So the probably way to do it, like I said, would be to have an aluminium angle or a store mold or something like that you fix to the brickwork. That's not fixed to the window. That still allows that movement to occur.
Okay, so do you get AbleFlex installed by the bricklayer for the expansion joints?
Sorry, can you just say that question again?
Does the bricklayer install an AbleFlex between the bricks for the expansion joints?
Yeah, so there needs to be an expansion material there, and generally those. So there is a requirement to have the compressible material there, but then also then to have it then sealed. So you need to have that compressible material, but then also have that joint generally sealed. So you'd have sort of a bond breaker, then that sealed on the outside.
So you'd have a Sikaflex on the outside.
Yep. With the compressible material. Yeah, the compressible
foam
material.
Should be a 10mm foam installed by the bricklayer.
Yes.
Yeah, well, I've had bricklayers say they don't do it.
I don't know how you would do it otherwise.
Will you put in a backing rod?
Yeah. I'll take that one on notice. I'll see if you can get away with just the backing rod. My understanding, it had to be a compressible material in there. I'll take that one notice, and I'll come back to Tim offline with an email, and he can then forward it on to everyone in terms of what the requirement is. But I'm happy to take that one notice and just confirm that, because it might also depend on the standards as well. But my understanding is there was required to be a compressible material there, but I don't know if just having the backing rod is sufficient, but I'll just double check to make sure, and I'll come back to you.
Yeah. That'd be great. Thanks, Michael. I'll provide that to everyone in Workplace once we get that back from you. All right,
Okay,
any
thanks.
other questions? All right, I think there are no more questions at the moment. So thank you for that presentation there, Michael. I think that'll be useful for everyone. And yeah, if you can get back to us on that question, I'll provide that to everyone after the meeting as well. And thanks for joining, everybody, and thank you, Michael.
Thanks, everyone. And so if you've got any questions, feel free to reach out either through Tim or directly to myself. Thank you.
Wonderful. See you all soon.